Welcome friends to the binary files module in C++. This is in the paper Object Oriented Concepts and Programming using C++ in the subject Information Technology. In the previous module, we have already talked about working with files, and especially the emphasis was more on text files. File is especially used for persistent data storage, and it is just a sequence of bytes which is stored in the storage media. There are two types of files, text files and binary files, which can be used in C++. Text files does the conversion of numeric data or objects into string before reading or writing, whereas in case of binary file, such conversion do not take place. The data is just in the raw form without any type of conversion, just the way it is stored in memory of the computer. By default, it considers text files. The general model of working with files, we have the files on the disk. When we say read the data is read from the file and it goes into the input stream, and from input stream it is stored into the variables or objects which are stored in the memory. In the same way, when we say write, the data from the main memory is written into the output stream first, and from output stream it goes to the file on the disk. Let us start working with binary files in detail. In binary files, as said, the data is stored in the raw format just the way it is stored in the memory, which is declared of int long. It will occupy 4 bytes in memory. When it is stored in ASCII, it is stored as character 6, character 5, character 5, character 3 and character 6. But when it is stored in the memory, it is stored in 4 bytes. Here the presentation of the byte is in hexa. So, it is stored as byte 00, 01, FF, FF. In the same way, when we press enter key, it is consisting of 2 characters, carriage return and line feed. But when it is stored in the memory, it is stored just as 1 byte \n. So, when it is stored in binary, the data is not in the human readable form. So, binary files data is not simply readable by human or simply editable by any text editors. So, why to use binary file then? Binary file provides faster read write operations because no conversion takes place. Another advantage is it uses less storage space. For example, if the character is of the if it is ASCII character, it will always store 1 byte, but if it is short integer, it will use 2 bytes in the memory, and the range of integer is from -32678 to 32767. So, otherwise it may use 5 to 6 characters. Similarly, for long integers, it may use with sign around 11 characters at the most, but when it is stored in binary file, it will use only 4 bytes. So, this way it occupies less space. And another advantage is it provides data protection up to certain extent, because the data is not human readable and it is not editable by the users using simple editors. Now, where to use binary files? So, obviously, due to these advantages, one should use binary files where there is large numeric input which is to be processed. So, those numeric inputs can be read from binary file or can be written into the binary file for later use. The applications which are having sensitive data like results of the students or some financial applications which we may like not to be tampered with simple editors, we can use binary files. Now, let us see working with binary files in detail. Working with binary files is very similar to working with text files, except the difference in the open mode of the file, where we need to include IOS : binary and the operations read and write. So, how to open binary file? As said, we need to specify IOS : binary as the in the open mode, which suggests that conversion should be suppressed. Now, there are two ways of opening the file just like text file using constructor. So, while defining the object itself, we can associate the stream with the physical file, or using open statement after creation of the file stream object. The syntax is also very similar, and both the form have same effect, and they work equally well with whether it is IF stream, OF stream or F stream object. The only difference here with text files is, with text files IO mode can be avoided and we can use default. So, for IF stream the default is in, for OF stream default is out, and for F stream default is in and out, whereas with binary mode we must specify the default in out or in out also for IF stream, OF stream and F stream respectively. So, see this example of opening binary file. Here in this example we have considered my file as the object of class IF stream. The data file which we are associating with my file stream is data.bin, and the IO mode which we have used here is ios : in and ios : binary. So, see this, that in is also required to be specified even though my file is IF stream object. Now, after any file IO operation, as we have seen with text files also, it is better to check whether the operation is successful or not. So, here we can check whether open is successful or not by using even dot open function. Here I have used if not my file, because any operation when it is successful returns true in the file stream, otherwise it returns false. We can also check the fail bit using the fail function, or good bit using the good function which is associated with the file stream. So, here we are just checking whether it is opened successfully or not. Now, once the file is opened, that means the physical file is associated with our file stream, input output stream. We can start doing some operations like reading the data or writing the data using the files. In binary IO, because it does not require any type conversion, the conventional insertion or extraction operators will not be efficient, but we can still use get and put method for reading or writing single characters, and the better way of doing this is by using read or write methods, which will work for any type of data, maybe numbers, maybe strings, maybe single characters, maybe objects, maybe structures, anything. So, first of all let us see how to write in the binary file. Obviously, when we are saying write, the file should be associated with either OF stream or F stream object, and the syntax for write is write, it takes two parameters. The first one is a pointer to a character buffer, and the second one is size, which is the number of bytes to be written in the file. It is the method of obviously OStream class, and it returns the reference to the OStream. Write always takes place from the current position in the file, and after writing it moves the file pointer, obviously the put pointer, size bytes ahead. So, let us see this example of writing one integer and one double variable. So, here the file is opened in OF stream, the name of the object is f out, the file is data.bin, and see this mode iOS out and binary. That means, the file is opened in binary for output purpose, for writing purpose. To write the value of integer I, that is 1, 2, 3, 4 in the file in binary, we need to use write method. So, we say f out dot write. Now, because the first argument is a pointer to a character, we should convert our item to the pointer to character, and therefore, we have used typecast char star here, and the address we are specifying. So, address of I is converted to character type, and then how many bytes are to be written. For that, we can use the size of to determine the size of the object. So, size of int. In the same way, we have written the double data into the file. Write takes place from the current position of the put pointer. So, if the put pointer is at the end of file, the file is extended, that means at the end data is appended. But if it is in between, then the existing data will be overwritten with the new data. To know the position of the put pointer, obviously we can use either telp or sigp method. Because this is binary write, this write method will not do any conversion of the data, neither it will add carriage return at the end of after writing the data. And please do remember that it will not even stop writing if the null terminator comes into the buffer array of characters. Whatever size is said, those many bytes will be written into the file, irrespective of maybe null character appears in between. Now, in case of error during write, the error may be due to maybe for example, it is out of disk space. The file stream is placed in the error state. So, it is the programmer's responsibility to check the error state and even clear the state after checking, but otherwise the error state will remain, the flags error bits will remain set only. The data which is written to the file using write method can be read accurately only by using read method. So, let us see now how to read the data from the binary file. To read the data from the binary file, we use read method, and here the file should be associated with either fstream or ifstream object. The syntax is very similar to write, the only thing is it is the method of istream class and it returns the reference to the istream, but otherwise both the parameters are very similar to the parameters in the write method. So, the first one is pointed to a character, so it is similar to some C type array of characters, and size is the number of bytes to be written to be read from the file. So, when we say read, it extracts size number of bytes from the associated file stream, and those extracted bytes are stored at the address which is given in the buff. So, this is a simple example of reading or reading integer and double data which we have written in the file data.bin. So, first of all we need to open the file. ifstream is the class, fin is the object of class ifstream, data.bin is the name of the file, and the mode is in as well as binary, and the method we are using is fin.read. Just like in case of write, the first is the address of the address in the memory where the data is to be stored. So, it is converted into char star and how many bytes are to be read and stored in this address. While reading the data, the programmer should take care of buffer size. If the buffer size is not enough, for example, I have the buffer of only 4 bytes and I am reading 7 bytes into it, then the next 3 bytes will be written, total 7 bytes will be written from the starting position. So, the last 3 bytes may corrupt some data if it is existing or overwrite the data. So, it is programmer's responsibility to check or to provide enough buffer. See this example, x is declared as long. So, obviously, it will use 4 bytes in the memory, and we have opened the file for input. After that, we read 7 bytes and it is to be stored at x, it should be converted into char star. So, when we read 7 bytes, so after the 4 bytes of x, the next 3 bytes may be corrupted or may be overwritten. Reading from binary file, again do not interpret or convert the data, because it does the operations on raw data. It does not assume anything about end of lines. So, it will not stop if \n appears, and neither it put null. In case of error, as with write, it is the responsibility of the programmer to check. Once the error bits are set, again they should be reset using the clear method, otherwise all the future operations will see the error bit set. In case of error, maybe all the size bytes are not read, we can use gcount method to see how many bytes are actually read, maybe less than size. In C++, no file operations cause the program to terminate. That means, it is the programmer's responsibility to check whether the file operation was successful or not. May call fail member function or other ways, like checking the file stream. As said, it is always set to true if the operation succeeds. So, one can even check the file stream or error bits like fail bit, EOF bit, and so on and so forth. Let us see now the examples of using binary files. Please do remember, when we are working with the files, maybe text files, maybe binary files, we require to include the library fstream in the program. In the following examples, we have shown only the code snippets, not the entire program, and wherever file is not closed, it is to be assumed that after the working with files is over, it is the files should be closed. This first example is of copying one binary file to another binary file. Now, here I have shown three versions. One is by copying character by character, the first one. The second one we will see where we are copying entire content at a time, reading entire content of the file and writing entire content into another file. And the third one where we will read blocks of the file and write only those blocks of specific size. Now, the first version here is copying by using reading one character at a time and writing one character at a time. Obviously, we require two files. One is the input file, the file which is to be copied, and one is the output file, which is where the copy is to be made. Here in this example, we have considered image1.jpg as the file which is to be copied into image2.jpg. So, after opening the file, it is better to check whether the files are opened successfully or not, and if they are opened successfully, then we will keep on reading from input file in here till end of file. In.get will read single character, and that single character is written into the output file out, which is image2 which is associated with image2.jpg. So, here we have used put method and get method to write and read a single character at a time. Now, here let us see read and write, where read is reading the entire file and storing it into the buffer in the memory, and from that buffer we are writing into the file. So, only single read and single write. In the previous case, it will read and write will be executed for as many bytes are there in the file. So, here to know the size of the file, we are using method tellg. So, with input file using tellg method will specify where, okay, first of all let us see here. When the file is opened with ifstream class, the mode is set at ATE, that means it is at the end of file. So, the get pointer is at the end of file, and therefore, when we say in file.tellg, it shows us the size number of bytes which are in the size of the file. So, first of all we need to allocate the buffer of that much size. So, we said buff is equal to new char size. So, we have allocated the buffer of size in the memory, and after that again it is required to put the position at the beginning of the file. So, get pointer is set at the beginning of the file using SIGG method. Now, from the beginning of the file we read size bytes into the buffer, and that buffer we are writing into the out file. So, this is how we read the entire file at a single time into the buffer and write it in a single write. The only problem may be when the size of the file is very large and the memory cannot be allocated when we say buff is equal to new char size. So, in such case it is better to use reading or writing of some small chunk of bytes. Let us see here, we are considering the block of size 2048, it can be larger than this also or smaller than this. In this example, we have considered 2048. So, the memory is also allocated into the buff of 2048 bytes. When the file is read here, I do not need to put it at the end because I am not interested in knowing the size of the file. And after opening the file successfully, we see till end of file, we keep on reading and writing, but how many bytes? Only the size bytes. So, here when we say in file dot read buff size, it will read 2048 bytes into the buff, and when we say write, it will write those many bytes. Now, the problem may be when it is the last block. In the last block, it might not have 2048 bytes. So, in that case, it is better to use G count method instead of saying size here, because in the last block the number of bytes read may not be same as 2048. So, in that case it will write only those many characters which are read. G count method provides how many characters are read, how many bytes are read successfully in the read. Okay. Now, another example in this case is how to deal with objects or structures, the complex data types. In this case, we will take the example of student class, where it has two data members, name and marks. Name is obviously a array of 20 characters in this case, and marks here we have considered as an array of 7 integers, which stores the marks in 7 subjects. Let us assume two methods, get student data and show student data, which are used to take the input of the student data and show the student data. We will not go into the detail of implementation, or neither we will see the implementations, because our emphasis is on working with files and not working with objects. So, how to write the objects in binary file? Obviously, first of all we will have to open the file for output. If we want to append into the existing data, we can use iOS app open mode with binary, and let us assume in this case that we will keep on asking the users whether the user want a new object to be written into the file or not. If he answers yes, then it will ask for the input, and once the input is taken, the object will be written into the output file, binary file. Here S obj is the object of the type student, and when we say S obj dot get student data, that means we are taking the input of the student data and storing into S obj. So, S obj is to be written into the file using write method, and in write method it needs to be converted to the char star, I mean to the pointer of the type char. So, we have used char star as the typecast, and how many bytes are to be written, again size of macro will help us to determine the size of the object. So, we have used size of S obj. So, those many bytes will be written into the file student dot date from current position of the put pointer. Now, once it is written, it can be read using the read method of the iStream class. For that, we need to open the file in the input mode. So, here we have said iOS in iOS binary, and till end of file we can keep on reading the data and displaying. This code snippet reads all the objects in the binary file and show them onto the screen. So, once the file is opened, while not end of file, we use read method. Where to store? It is to be stored at the starting address of as obj. So, it is pointed to the character, and how many bytes are to be read, then it is again size of as obj. So, very similar to write method. Let us see how to delete the objects from the file. Suppose we have the objects, student objects stored in the binary file, and we want to delete the student named Tina. There are few options, because when we want to delete, it will create the empty space in between, which is not possible because these are the sequential files, and therefore, all the records other than the record to be deleted are to be copied into another file. That is the physical deletion. When physical deletion is done, it requires all the remaining records or objects to be copied in another file. A better option may be just to have one more bit or byte, which is sat for showing whether the object is deleted or not, to just have the status deleted or not. In that case, it does not require to be copied in all the records in another file, and it will save the time. Here we have seen, we have shown only physical deletion in this scenario. So, open the input file and open the file where the remaining records are to be written. So, here we have opened the file named temp.date. So, temp.date will have all the records except the record of Tina, which is to be deleted. So, start reading the input file, till end of file we can go. So, fin.read into as obj at the starting address of as obj, and how many bytes are to be read is size of as obj. We need to compare here whether the name is Tina or not. If it is not Tina, then we write it into the temp file. If it is Tina, then we do not write and we just read the next record. So, this way all the remaining records will be written into the file which is associated with fout stream, that is temp.date. Now, it is done. If we want again the name of the file to be student.date only, then we will have to remove the student.date and then rename temp.date as student.date. Can we modify the objects in binary file? Suppose I want to modify the marks of Tina, then it is possible and be done in place. That means, it may be modified at the same place. So, here in this case the file is required to be opened in Fstream, because we will read the data also and we will again rewrite after modification. So, it should be used for read as well as write. So, the file object should be of the class Fstream. Here the name of the object is file, then file is to be out and binary, because we are dealing with binary files, the data is in binary, and the loop will be till we find. So, read the record object, compare whether it is Tina. If it is Tina, then get the new details of the marks. Now, once it has moved ahead, suppose the object is of 20 and 7 into 4, 28. So, 48 bytes, then the pointer has moved 48 bytes ahead. So, put back at the previous, at the starting position of the object, and for that here we have used position is equal to -1 into size of obj. Size of obj, if it is 48, then here it will be -48. So, when the position of the put pointer is to be set from current position 48 bytes in the backward direction. So, for that we have used file.seek p position, which is -48 from current position. and at that position we are writing the record back. So, this is how we can modify the object. After modifying the object, either we can break the loop if there are no more Tina, or we can continue, but we will not find Tina. So, it is better we say break here. Random access, randomly accessing the nth object from the file is also possible. So, what we need is to know the number of bytes to be skipped. So, if I want to read nth record, my pointer should be at the starting of nth object. So, previous n minus 1 objects are to be skipped. That means, we are supposed to set the pointer after n minus 1 into 11th record, then 480 bytes are to be skipped. My position should be at 480 in that case. And for that we say position is equal to n minus 1 into size of OBG, then we use seek g for setting the get pointer from where we want to read. So, we are not reading sequentially from first object, we are going directly to the 11th object here in this case, and after that we can simply read and work with the file. Here it is just showing the data. So, this way we can read and write at any position. Sometimes while converting into char star, we have in our examples used just char star typecast. One may also use reinterpret cast to do the conversion, irrespective of what type of objects are, they are always to be converted into the pointer char star when we say like this. So, let us summarize now what we have learnt. Working with binary files is working with raw data, no type conversion takes place, no numbers are converted to strings, or no strings are converted into numbers, or neither objects are converted into the corresponding ASCII string or vice versa. When we want to use files, we must include fstream library into the program, and we should also set iOS binary flag along with either in, out, or append or ATE, whatever flag we are using. We can use either get or put methods or read and write methods. Get and put will be used only for single character, whereas read write can be used for any type of data, maybe single character, maybe structures, maybe objects, maybe numeric, anything, maybe strings. It is the programmer's responsibility to see the errors. Program will not stop if some error occurs or some file IO fails. In case of any error, the bits are set in the error state, and those bits remains set unless and until they are cleared by using some method like clear. So, it is all the programmer's responsibility to check the errors during file operations, as well as to clear those errors using the clear, those error bits using the clear method. Files, binary files are especially to be used for efficient operations with more numeric type of data, or even where the files are to be protected by normal text editors. The data may not be hampered in that case. So, this is how we can use binary files. Thank you all for listening carefully. I am sure it must have helped you. Please practice to get confidence in working with binary files. Thank you once again.